I will discuss the multi-choice questions in the thermodynamics. Question number 1. Point out the wrong statement in relation to enthalpy. Option 1. It is a state function. Option 2. It is intensive property. Option 3. It is independent of the path followed for the change. 4. Its value depends upon the amount of the substance in the system. Now, if we just study the various properties of the enthalpy, based on the various properties of the enthalpy, we can say enthalpy is a state function. Next, it is not intensive property. Here in this question, we have to identify the wrong statement. In the option 2, they have given that enthalpy is intensive property. Actually, enthalpy is a state function and it is extensive property. Therefore, option 2 is wrong. Hence, answer is 2. Next, question number 2. Which of the following is 0 for isochoric process? Means isochoric process means any process which takes place at a constant volume. That means during the isochoric process, volume will remain constant. Volume change will not take place. Therefore, dV is always equal to 0. Next, during the isochoric process, if we supply heat energy, because of maintenance of the constant volume, definitely pressure changes will take place. Hence, option 1 is wrong. When we supply the heat energy, because of maintenance of constant volume, the pressure will increase, therefore temperature also will increase. Therefore, option 3 is also wrong. Next, at constant volume, energy changes can happen. Therefore, again in the fourth option, they are given that internal energy change is 0. Therefore, first option, third option, fourth option are wrong. Therefore, answer is definitely answer is 2. Next, question number 3. The change in enthalpy and the change in internal energy accompanying a gaseous reaction. They are given 4 statements. In the first option, they said that enthalpy change is always greater than internal energy change. Next, second option, enthalpy change is less than internal energy change if the total number of moles of the products is greater than that of the total moles of the reactants. Next, in the option 3, they are given that enthalpy change is always less than internal energy change. Next, option 4, they said that enthalpy change is less than internal energy change if the number of moles of the products is less than the number of moles of the reactants. Out of these 4 options, now we have to select the correct option. So in general, the relation between enthalpy change and the internal energy change for a chemical reaction can be studied through this relation. Del H is equal to del E plus del N RT. Based on this relation, we can study the relation between enthalpy change and internal energy change of the reaction. Here del N represents the difference in the total moles of the products to reactants. Therefore, del N is equal to number of moles of gaseous products minus number of moles of gaseous reactants. Therefore, the exact relation between enthalpy change and internal energy change depends on the del N value. For example, if del N is equal to 0, therefore del N RT become 0. Therefore, del H is equal to del E. Next, if del N is equal to positive, for any reaction if del N is equal to positive, automatically the magnitude of the del H becomes greater than del E. If del N is equal to negative, automatically the magnitude of the del H becomes less than del E. Del N A. Next, when the magnitude of the del N will become equal to 0, when it will be more and when it will be less. If you observe the various reactions, say for example, H2 plus I2, reversible arrow 2HI. Here, while calculating the del N, we have to consider only the gaseous state moles of the products and reactants. For this reaction, del N is equal to total moles of the gaseous state products 2 minus total moles of the gaseous state reactants, again 1 plus 1 2. Here del is equal to 0. That means for this reaction, the enthalpy change is equal to internal energy change. Del H is equal to del E. Next, if you observe this reaction, in this reaction, during the decomposition of the CaCO3, here we are getting the calcium oxide and CO2. For this reaction, del N is equal to 1 minus 0, 1. Therefore, here del N is equal to positive. Since del N is equal to positive, del H must be definitely greater than del E. Next, another example here. Let us take this example. N2 plus 3H2, reversible arrow 2NH3. In this reaction, del N is equal to 2 minus 4, therefore minus 2. Since del N is equal to negative, therefore here del H is less than del E. This is the relation between enthalpy change and internal energy change. Based on these results, now we can select the correct option given in the question. Del H is always greater than del E. See, since the magnitude of the relation between del H and del E is decided by the del N value, therefore we can't say del H is always greater than del E. Therefore, first option is wrong. Next, in the second option, they said that del H is less than del E. Del H is less than del E, only the number of moles of the products is greater than the number of moles of the reactants. Here you see here, in this reaction, total moles of the products is equal to total moles of the reactants. In this condition, del H has become equal to del E. Next, in this condition, the total moles of the products is more than the total moles of the reactants. Therefore, del N has become positive. Here del H is greater than del E. But here, in the second option, they said that del H is greater than del E only if the total moles of the products is greater than the number of moles of the reactants. Number of moles, del H is greater than del E when the total moles of the products is greater than the number of moles of the reactants. Next, in the third option, they said that del H is always less than del E. So we can't say always less than del E. Therefore, third option is wrong. Next, in the fourth option, they said that del H is less than del E only if the number of moles of the products is less than the number of moles of the reactants. Total moles of the products is less here. Total moles of the products is less than the total moles of the reactants. In this condition, so del H is less and del E is more. Therefore, option 4 is correct. Next, question 4. A schematic plot of lnk versus inverse of the temperature for the reaction is shown below. From this graph, we have to select the correct option. Therefore, first let me represent the graph given in the problem. Here on y-axis, they have taken ln k equilibrium constant and here inverse of the temperature. The shape of the curve shown in the graph is this one. Based on the shape of the curve, we have to select the correct option given in the problem. So, first let us discuss the mathematical expression related to this graph. So, in this equilibrium chapter, we might have studied that the relation between the temperature and equilibrium constant can be expressed through this one. K is equal to A into e power minus del H upon RT. Now, we take the logarithm on both sides. ln k equilibrium is equal to ln A minus del H upon RT. Del H upon RT. Now, this expression, it resembles y is equal to minus mx plus c. Therefore, this is the y is equal to minus mx plus c. Next, the exact shape of the curve depends on the sign of the del H. So, for example, if del H is equal to positive, the expression will remain like this. ln k equilibrium is equal to ln A minus del H upon RT. If del H is equal to negative, then this expression will become ln k equilibrium is equal to ln A minus del H upon RT. Therefore, it becomes ln k equilibrium is equal to ln A plus del H upon RT. This is the expression. Next, now according to this shape of the curve, see the exact shape of the curve, see this if you extrapolate to intercept the y-axis. So, here the y-intercept is equal to ln A. Here y-intercept is positive, next the slope is also positive. So, when the slope will become positive, see if the del H is negative, then entire expression will become plus del H upon RT. Therefore, since the slope is positive, therefore the del H must be definitely negative. If del H is negative, then the second term will become positive, hence then the graph will suit with this expression. Therefore, now you select the option where enthalpy change is shown negative. Enthalpy change is shown negative only in the first option, hence answer is first option 1. Next, question number 5. Work done during isothermal expansion of 1 mole of the ideal gas from 10 atmospheres to 1 atmosphere at 300 Kelvin is. So, they are asking the numerical value of the work done by the 1 mole of the ideal gas under isothermal conditions. So, let us recollect the formula that is applicable to calculate the work done by the gas. W is equal to minus nRT ln V2 by V1, or W is equal to minus nRT ln P1 by P2. Here minus, here the number of moles of the gas is 1. Next, in the problem itself they have given the value of the R. R is given as 2, therefore R is equal to 2. Next, the temperature of the gas is T is equal to 300. Next, this is a 2.303 log P1 upon P2, that means initial pressure upon final pressure. Initial pressure is 10 atmospheres, final pressure is 1. Therefore, this is minus 1 into 2 into 300 into 2.303, log 10 is 1. Log 10 is 1. So, therefore, now this is a 4.6, that is a 1381. So, 1381, answer is 1381.8 calories. Therefore, answer is 3. Next, question number 6. For the given reaction, so I will represent the reaction first. C3H8 in the gaseous state, it is undergoing combustion to give the carbon dioxide and water. This is the reaction given in the problem. This reaction is taking place at constant temperature. Now, we want the relation between the del H and del E. So, in order to find out the relation between del H and del E, the suitable expression that we have to use is del E plus del N RT. First, to calculate the del N. Del N means number of moles of gaseous products minus number of moles of gaseous reactants. Total moles of the gaseous products 3. Total moles of the gaseous reactants is 5 plus 1 4 6. Therefore, minus 3. Del N is equal to minus 3. Next, del N is equal to minus 3. Therefore, del H is equal to del E minus 3 into RT. Minus 3 into RT. Therefore, del H minus del E is equal to minus 3 RT. Minus 3 RT. So, in the problem they are asking the difference of enthalpy change and internal energy change. Difference of enthalpy change and internal energy change is equal to minus 3 RT. Hence, option is 3. Next, question number 7. Mixing of non-reacting gases is generally accompanied by first option decrease of entropy, second option increase of entropy, third option change in enthalpy, fourth option change in free energy. So, the question is mixing of non-reacting gases. When the non-reacting gases are mixed with each other, because of the non-reactivity, the entropy of the system always increases. So, option is 2. Question number 8. An irreversible process occurring isothermally in an isolated system leads to. That means the particular change is taking place at constant temperature, and moreover it is in isolated system. Isolated system is the system from which heat is neither absorbed nor liberated. That means the energy changes and the mass changes with surroundings will not take place. So first option is zero entropy. Second option is increase in total entropy of the system. Third one is a decrease in total entropy of the system. Fourth one is none of these. So inside the isolated condition, if a particular irreversible change takes place, always the entropy of the system will increase. In general, wherever irreversible change takes place, entropy of the system always increases. Hence answer is 2. Next, question number 9. When enthalpy and entropy change for a chemical reaction are minus 2.5 into 10 power 3 calories and 7.4 calories per degree respectively, predict the reaction at 300 Kelvin. The options given in the problem are the spontaneous, second one is reversible, third one is irreversible, fourth one is non-spontaneous. That means based on the data given in the problem, we have to find out whether the reaction is spontaneous or non-spontaneous. So whenever if the enthalpy change and entropy change are given, in order to find out the spontaneity, you calculate the del G through this reaction, through this expression. This is the expression through which we can calculate the enthalpy free energy change. Here in the problem, they are given the enthalpy change. The enthalpy change given in the problem is minus 2.5 into 10 power 3 calories. Next, minus temperature 300. Next, entropy change. Entropy change given in the problem is 7.4 calories. So you calculate the free energy change. This is minus 2.5 into 10 power 3. Next, here you find out the magnitude of the TDS. Magnitude of TDS is minus 300 into 7.4. Here 2920. Therefore, this is a minus 2920. Minus 2920. Therefore, minus 2.5 into 10 power 3. Minus 2.9 into 10 power 3. Therefore, the answer is minus 5.4 into 10 power 3. Since the free energy change is negative, therefore we can say the reaction is spontaneous. So answer is 1. Next, question number 10. The total entropy change for a system and its surroundings increases if the process is. So in general, when any process is reversible, the total entropy change is always 0. In reversible process, del S total is always 0. Next, in irreversible process, del S total is always positive. Next, in endothermic process, because of absorption of energy, del S total is always positive. Next, in exothermic process, del S total is always negative. So these are the total entropy change accompanied in the various types of the process. In this problem, we have to find out the option where entropy change is positive. If the total entropy change for a system and its surroundings is increases, that means entropy change must increase. So if the process is irreversible, then only the entropy change will become more or increases or positive. So option is 2. Next, question number 11. The standard entropies of the CO2, next carbon and oxygen are given in the problem. Now we have to find out the the standard entropy change during the formation of the CO2. Therefore, first you represent the formation reaction for CO2. For the formation of the CO2, the reaction is carbon in graphite form plus oxygen in the gaseous state gives CO2 gas. For this reaction, we have to calculate the total entropy change. The total entropy change for any reaction is entropy change of the products minus entropy change of the reactants. Entropy change of the products means entropy change of the CO2. So, in the problem, the entropy change of the CO2 is given, that is 213.5 minus entropy change of the reactants. Reactants means entropy of the carbon and entropy of the oxygen. Entropy of the carbon is given as 5.69 and entropy of the oxygen is given as 205. This is the total entropy of the reactants. Therefore, 213.5 minus, here add these two values. This is 9601 to 10.69. Next the net entropy change. The net entropy change is 2.81 calories per degree. Therefore, answer is 2. Next, question number, at 300 Kelvin, the reactions which have following values of thermodynamic parameters occur spontaneously. They are given the thermodynamic parameters. Based on the thermodynamic parameters, we have to decide which thermodynamic parameter is suitable for spontaneity. In the first option, they have given that free energy change at standard conditions is given as minus 400 kilojoules per mole. So, whenever for any reaction, if the free energy change is negative, the reaction is always spontaneous. Therefore, answer must be 1. But before coming into the conclusion, let us verify the other options. So, in the second option, they given the enthalpy change and entropy change. Based on the enthalpy change and entropy change, again you calculate the free energy change. Del G is equal to del H minus TdS. Here, the enthalpy change is given as 200. Next, the reaction is taking place at 300 Kelvin. Therefore, 300. Next, the entropy change is given as minus 4. Therefore, this is 200. Minus of minus plus, that is 1200. So, 200 plus 1200, so plus 1400. So, finally, then the free energy change has become positive. Since the free energy change is positive, the reaction is not spontaneous, hence option 2 is wrong. Similarly, verify the data given in this third option. In the third option, they are given the enthalpy change as well as entropy change. Again, calculate the free energy change. Enthalpy change is 200 minus temperature is 300. Next, the entropy change is given as 4. Therefore, this is 200 kilojoules. This is minus 1200. 1200 means minus 1.2 kilojoules. Therefore, this is my 198.8 kilojoules. Again, the free energy change has become positive, hence the reaction is non-spontaneous. Therefore, third option is also wrong. Del H is equal to del G is equal to del H minus TdS. That is 200 minus 300 into 40. That is 288 kilojoules. Here again we got the free energy change with positive sign, hence the option is again, fourth option is also wrong. So, answer is 1. Question number 13. Del G naught for the reaction is given. From based on this del G naught, we have to calculate the equilibrium constant. The reaction given is X reversible arrow Z the del G naught is equal to minus 4.606 kilocalories. Based on this, we have to calculate the equilibrium constant. The relation between free energy change and equilibrium constant is this one, minus 2.303 RT log K equilibrium constant. Del G naught. R value is 2, temperature 300, equilibrium constant. It's minus 2.30, this is 4.606 into 10 power 3. This is 2 times, this 2 and this 2 will get cancelled. Temperature is 500, therefore this is 1000 here by 500, this is 2. Okay. Therefore K equilibrium constant is equal to 10 power 2, means 100. Therefore answer is 1. Next, question number 14. What is the free energy change when 1 mole of the water at 100 degrees Celsius and 1 atmosphere pressure is converted into steam at 100 degrees Celsius and 1 atmosphere pressure? So, represent the reaction which involves the conversion of liquid water into steam. This reaction is taking place at 100 degrees Celsius and at 1 atmosphere pressure. So, since 100 degrees Celsius is the boiling point of the water and since 1 atmosphere is the equal to the surroundings pressure, therefore, at 100 degrees and at 1 atmosphere pressure, when the liquid water and vapor form of water are in equilibrium, then the del G is always equal to 0. Hence, del G is equal to 0, hence answer is 4. Next, question number 15. So, for a reaction at 25 degrees Celsius, enthalpy change and entropy changes are given. Based on these enthalpy and entropy changes, we have to calculate the Gibbs free energy change. The Gibbs free energy change, del G is equal to del H minus T ds. Here in the problem, the enthalpy change is given as minus 11.7 into 10 power 3 joules per mole per Kelvin. Next, the temperature is 25 degrees. 25 degrees means 298 Kelvin. Next, the entropy change is given as minus 105 joules per mole. Therefore, simplify the TDS first. This is 298 into 105. 105. So, here if we simplify it, we will get this value 4. Next here 8, 9. So, this is minus 11.7 into 10 power 3 minus 31290 joules. 3190 joules. So, therefore, now this is a minus. So, minus of minus it becomes plus. Therefore, now the free energy change is equal to 31290 minus 11700. Here 0, 9, 12 minus 7, 5, 10 minus here 10 minus 1, 9, here 2, 1. So, answer is 19590 joules per mole or 19.59 joules per mole. Therefore, answer is 2. Next, question number 16. The essential condition for the feasibility of reaction is that first option, the reaction should be exothermic. The entropy of the products must be larger than that of the reactants. The reaction is to be accompanied with the free energy decrease. The reaction has to possess high activation energy. The essential condition for the feasibility of the reaction is the reaction must be accompanied with the decrease of free energy. So, answer is 3. Next, question number 17. In irreversible process taking place at constant temperature and pressure, in which only pressure volume work is being done, the change in Gibbs free energy and the change in entropy must satisfy the criteria. So, if the reaction wants to be spontaneous, the free energy change must be less than 0 or negative. Similarly, the entropy change must be more than 0 or positive. So, by satisfying these two conditions, the entropy change and free energy change are shown in the second option correctly. Hence, answer is 2. Next, question number 18. The enthalpy change and entropy change for a reaction at atmospheric pressure are given as plus 30.558 kilojoules and plus 0.66 kilojoules per Kelvin respectively. The temperature at which the free energy change will be 0 and below of this temperature the nature of the reaction will be. They are asking in the first statement the temperature at which free energy change is 0. See, in order to calculate the free energy change 0, use this expression. If the free energy change wants to be 0, then del H is equal to TdS. So, therefore, in this condition, enthalpy change will become equal to entropy TdS. Therefore, temperature is equal to del H upon del S. Here the enthalpy change is given. The enthalpy change given in the problem is 30.558 kilojoules. Next, the entropy change. The entropy change given in the problem is 0.66. This is given in joules, therefore convert into kilojoules. Both are given in kilojoules. Therefore, the temperature is approximately, if we calculate it, we will get the 463 Kelvin. So, when the temperature is 463 Kelvin, at that temperature the free energy change of the reaction is 0. Next, the second statement in the problem is what would be the nature of the reaction below this temperature. That means, see, del H minus TdS is equal to del G. If this del G wants to be 0, the magnitude of this term and the magnitude of this term must be equal. Now, if we decrease the temperature, the total magnitude of the second term will decrease. Hence, the reaction becomes spontaneous. Therefore, below 463 Kelvin, the reaction becomes spontaneous. So, by satisfying these conditions, in the fourth option they have given correctly. Therefore, answer is 4.